So then you did the cosine of 180. So we're doing the cosine of pi, which is the same thing as 180. That's fine. I will tell you that do not get in the habit of changing radians to degrees all the time, because you'll end up changing radians to degrees and then changing it back, and it's just going to be time consuming, okay? And you need to really just get yourself to think in radians, okay? So here's just as a quick review. This is what we went over yesterday, that when you're in the unit circle and you have an x-coordinate and a y-coordinate, the x-coordinate was sine or cosine? And the y-coordinate was, do you remember this? Sounds like no. Here was our notes yesterday. The sine was your y-coordinate, right? We did the unit circle with a hypotenuse of 1, so the sine was opposite over hypotenuse, which is y over 1, which is just y. So the y-coordinate is the sine of your angle. The x-coordinate is the cosine of your angle. So y is the sine, and x is the cosine. Okay? So the 30-degree angles, the 45-degree angles, and the 60-degree angles need to be memorized. They all come from SOHCAHTOA and the special right triangles. But the 0-degree angles and the 90-degree angles and anything with a reference of 0 and a reference of 90, I believe really should come from your unit circle. And here's why. If we have a unit circle and the radius is always 1, right? What are the coordinates at the end of this? So if this is a 0-degree angle, there's my terminal ray and my initial ray. What are the coordinates? What comma what? If this is 0, 0, what's this? 1, 0. So that's the sine. Sine is the y-coordinate. That's the sine of a 0-degree angle. And this is the cosine of a 0-degree angle. That's what your memorized chart would tell you anyway, okay? If we open up to a 90-degree angle and we put our terminal ray here, what's the point at the end of that terminal ray? What are the coordinates? 0, 1. So guess what? That's the sine of a 90-degree angle is 1, and that's the cosine of a 90-degree angle is 0. Good? Over here, what are these coordinates? Negative 1, 0. I guess second of all, that's a 180-degree angle, correct? Or pi, which is what we're doing right now in that homework question. Cosine of pi. Well, the cosine comes from the x-coordinate. So the cosine of 180 degrees is negative 1. And the sine of 180 degrees is 0. Do you follow? Okay. And then down here, this is 0, negative 1. There's the sine of what angle measure is this? 270. And the cosine of 270 is 0. Okay? So we can do that with the unit circle thought with all the 1, 0, 0, 1s, negative 1s, and so forth. And the idea that the x is your cosine and the y coordinate is your sine. Do we follow? We're gonna piggyback off of that today. I will tell you that's one of the ways you can do it, but I will also tell you this. I always had a separate chart for sines. So and by the way, these are kind of ways just to remember these quadrantal angles, the ones that don't land totally in a quadrant, they're kind of more on the border. So when it comes to doing all students take calculus, it doesn't really work if the terminal ray isn't in a quadrant. So with my sine graphs, I remember that sine of 0 is 0. If that's the case, then this is a 0 over here because it has the same reference angle, right? And then the sine, once you get up to 90, has increased to 1. And that's a positive 1. And on the opposite pole, it's a negative 1. So this little chart tells you that the sine of 0 is 0, which is a memorized value. The sine of 90 is 1. This also has a reference angle of 90. So the number is also 1, but it's a negative. And here's why. all students take calculus. Sine is positive here and here. So it makes sense that sine is positive in between those two quadrants as well, right? Sine remains positive this entire time. Then sine is negative this entire time. Okay, it's negative here and it's negative here, so it makes sense that it would be negative on that border between two negative quadrants. And so reference angle of 90, you get 1, but this one's positive. Reference angle of 90 here, but it's negative 1. Okay, so sine starts at 0 and increases up to 1. Cosine, on the other hand, starts at 1. And by the time you get up to the cosine of 90, it's dropped to 0. And what do you think this is? Negative 1, because it's the opposite pole, and this one is still 0. And again, this makes sense, because think about all students take calculus. Cosine is positive here and here. So it makes sense that the cosine right in the middle of a 0-degree angle is also a positive 1. On the flip side, cosine's negative here and cosine's negative here. So it makes sense that on the border between two negative quadrants for cosine, that's also going to be a negative. The reference angle is 0, so you still get the 1 and the 1, but this side's positive and this side is negative. So I really just showed you the two different ways, whatever you want to capitalize on, of remembering those quadrantal angles. Because the all students take calculus doesn't really help you on those. Does that make sense? Because you're in between quadrants. I mean, it does, but it's a stretch. You can better remember it based on the coordinates or based on just these two individual charts, one for sine, one for cosine. Okay? So back to that, the cosine of pi is negative 1. The cosine of pi is negative 1. Both charts will tell you the same thing. And that answer is number 2. Okay? Other questions? Nate? Get out of town. This guy, person on a Ferris wheel. This one deserves a picture. Okay, here's a Ferris wheel. Person is 45 feet from the center, and they're at an angle of 120. So when I draw my Ferris wheel, I'm going to draw it on an XY axis. Here's the center of my Ferris wheel. The person's at an angle of 120, so they're over here somewhere, right? 120, 180. There's my person sitting on the Ferris wheel, 45 feet from the center. So that's 45 feet. They want to know how high above. So they want to know the height above the center. Here's the center line of the Ferris wheel. They want to know how high above that they are. So they're essentially looking for that. Are you with me? Okay, so we have a triangle, and what's this reference angle? 60. So we would just use a little SOHCAHTOA here. The sine of 60 equals the opposite side, which we're looking for, over the hypotenuse of 45. The sine of 60 should be a memorized value for you, root 3 over 2. And then we would just cross multiply. 45 times root 3 equals 2x, and then divide both sides by 2, and you'll have your answer rounded to the nearest foot. Does that make sense? Anything else? Okay. Pass that forward. Nate, if you can grab Isaiah's off his desk, please, that would be helpful. Please and thank you. So the unit circle came up yesterday. Today's really the day that we're going to do it. I did this chapter a little out of order from the way the source that I steal everything from does it. See, yesterday I told you that the coordinate, the xy coordinate, was cosine comma sine, and I just did that again here. Cosine comma sine. That's true in the unit circle, because in the unit circle, what's the radius? 1. So it's really like 1 times cosine and 1 times sine. The real rule is this. This will apply to all circles, no matter what the radius. The x-coordinate is the radius times the cosine, and the y-coordinate is the radius times the sine. We don't need that in the unit circle because it's just 1. The radius is just 1. Do you follow? Okay, so when we're looking at any circle, the x-coordinate equals the radius times the cosine, and the y-coordinate is the radius times the sine. So in our first exercise, we're going to put this to good use. A circle centered at the origin has a radius of r. The terminal side of angle theta intercepts the circle in quadrant 1. We'll draw that. And there's some circle at the point x, y is the point there. So when you're given a point, you are given a way to label the legs of your triangle. So if I drop my triangle, what is the label for this leg? It's not a number, it's a variable. X. And what is the label for this leg? Y. And what is the label for this leg? No, it's not the unit circle here, is it? It just says a circle centered at the origin has a radius of r. So that's r. This particular one is not the unit circle. So it wants us to find the value of x and y in terms of r and theta. So this is our theta. So we're essentially going to just prove to you why this is what it is. Okay? And it's going to be, again, back to SOHCAHTOA. So the sine of theta, according to our picture, is what over what? Y over r. And this says to find the values of x and y. So we're going to solve for y. How do I get y all by itself? How do I undo dividing by r? Multiply both sides by r. So that'll cancel and you'll get y equals r sine theta. That's where your y coordinate equaling r sine theta comes from. SOHCAHTOA. And then I'll do the same thing but with the cosine of theta. The cosine of theta is adjacent over hypotenuse, so x over r, and I'll use that to solve for x. So I multiply both sides by r, those cancel, x equals r cosine theta. And that's where your x-coordinate comes from. That is truly all this problem was doing. It's kind of proving to you why this is what it is. This is based off of SOHCAHTOA. The fact of the matter is you just need to memorize that. You know if you're given a coordinate, an x-coordinate, that equals r cosine theta. Okay? These two right here. For just the exploration of it, let's look at tangent of theta. What would that be in our picture? Y over x. We're going to expand upon this because we can substitute out the y and replace it with what? What's an equivalent expression for y? What does y equal? R sine theta. And what does x equal? I can take out x and replace it with r cosine theta. And I can simplify this, right? What cancels? The r's. So tangent is the sine theta over cosine theta. That's going to be a popular thing for you to remember. Tangent is sine over cosine. I did already tell you that in one context. When did I tell you that? That tangent was sine over cosine. How about this day when we were filling this in? I told you to get your tangent column. You could always take this number and divide it by that number because it's your sine value divided by your cosine value. If you want the tangent of 0, you are going to memorize it. But it is the sine of 0 divided by the cosine of 0. Okay? And there's really your proof as to why that is. All right, now we'll get into numerical examples. This exercise. If an angle of 150 is drawn, that's going to be right here. 150. There's my initial ray. Drop your triangle. They're asking for the coordinates that lie on the unit circle. So it's a small detail, but when you read that, you know that your hypotenuse is 1, right? So your x-coordinate is going to be r cosine theta, and your y-coordinate is going to be r sine theta. So what's your r? 1. And what is your cosine of this theta? This is, what's our theta? 150? So 1 times the cosine of 150. And this will be 1 times the sine of 150. Well, we need to pause and think about what is the cosine of 150. This is a project. First of all, is it positive or negative? Is cosine, all students take calculus, is cosine in this quadrant positive or negative? Negative 1 times, and what's the reference angle? 30, so what's the cosine of 30? Correct. And on the second coordinate, for the y-coordinate, is sine positive or negative here? So that's going to stay positive, positive 1 times, and what is the sine of reference angle 30? 1/2. So when you just kind of clean this up, negative 1 times root 3 over 2 is negative root 3 over 2. That's your x-coordinate. And 1 times 1/2 is 1/2. So those are the coordinates of the point on the unit circle at the end of that terminal ray. Negative root 3 over 2, comma, 1/2. So if you needed to label the legs, this leg would be negative root 3 over 2, and this one would be 1/2. Any questions? Okay, let's look at the next one. Draw an angle of 5 pi over 3. What quadrant? Here's 3 pi over 3. This is 6 pi over 3, right? So 5 pi over 3, very good, is going to be a 4th quadrant angle. Drop your triangle. This is on a circle with radius 5, so that means that's your hypotenuse, right? So this is like a certain case where like you think, well, they only give me one side of the triangle, so I cannot find the other two. And the truth is you can't find the other two with the Pythagorean theorem like we've been used to doing, but you can find the other two based on finding these coordinates of this point and then working backwards. So again, our x-coordinate is going to come from r cosine theta, our y-coordinate is going to come from r sine theta. So our r is 5, and we want the cosine of 5 pi over 3, and then 5 times the sine of 5 pi over 3. And our side project is really finding the cosine of 5 pi over 3 and the sine of 5 pi over 3, both of which are two-step processes, because we got to think plus or minus, and then we got to think value. So in the 4th quadrant, is this cosine of 5 pi over 3 going to be positive or negative? So positive 5 times, what's the reference angle? Pi over 3. Remember, this is one of those ones you don't really have to think about. 5 pi over 3, pi over 3. So what's the cosine of pi over 3? That's where knowing your table very fluently is going to come in. Cosine of pi over 3 is 1/2. So that would be 5 times 1/2, comma. Is the sine in this quadrant going to be positive or negative? Negative. So it's going to be negative 5 times, And then reference angle is pi over 3, so the sine of pi over 3, again, this is where just being fluent with your values is going to come in, radical 3 over 2. So now just to clean up, you're going to get 5/2, comma, negative 5 root 3 over 2. Those are your coordinates. Does the positivity, negativity of those coordinates make sense? To get to this point, do we have a positive x coordinate and a negative y coordinate? Absolutely. So this length of this, so we can find the two side lengths of this triangle. It's just not by the Pythagorean theorem. So that's 5/2, and that's negative 5 root 3 over 2 units long. Okie doke. So we already did all that. That's just kind of outlining the steps. This next example tells us that all the points on the unit circle must satisfy the equation x squared plus y squared equals 1. Why do you think? That's because anytime you're on the unit circle, your hypotenuse is 1, right? And that's just the Pythagorean theorem, right? X squared plus y squared has to equal 1 squared, technically. But they don't put the squared there because 1 squared is 1, right? So this is just saying, those are your coordinates, x and y. Yes, they're the side lengths of your triangle, but they're also the coordinates of that point, x, y. So we're just verifying that this is on the unit circle by showing that this is true. Take the x coordinate, negative root 3 over 2 squared, plus the y coordinate, 1/2 squared, is supposedly going to equal 1. When you square this, what's a negative squared, first of all? Positive. What's root 3 when you square it? And what's 2 when you square it? So that's 3/4 plus 1/2, you can square the numerator, square the denominator, will be 1/4. And can you verify that 3/4 plus 1/4 is 1? 4/4 equals 1, check. So that point does lie on the unit circle. Okie doke. Next exercise. A circle centered at the origin has a radius of 10. The terminal side intercepts the circle in quadrant 2. So I'm just going to draw any quadrant 2 angle. I'm going to drop my triangle, and which side can I label and what? Hypotenuse is 10. This is point C, they're calling it. The y coordinate is 8. Interesting. So it's something, comma 8. What does that allow you to label in the triangle? Which leg? The horizontal leg or the vertical leg? Right here. 8? No. Vertical, that's the y coordinate, right? So you go left something, that's your x coordinate. I know it's negative, that's about all I know. And this is 8. So by giving you one of those coordinates, now we can use the Pythagorean theorem, and you should kind of know this already because it's one of your triplets. What is this? Would you say, Nate? Negative 6 though, right? Because we're going in the negative direction. What's now the value of cosine? Well, here's your angle. Cosine is adjacent over hypotenuse, negative 6/10, which reduces to which of those options? Number 1, negative 3/5. Okay? And these two exercises are just more practice of what we had on the front. Draw a rotation diagram for 225. What quadrant? Correct. 225. Drop your triangle. We're looking for the point at the end of that. So, unit circle, that's 1. So our x-coordinate is coming from r cosine theta, our y-coordinate from r sine theta. So do we even need to write the 1 times cosine? No. So it's just the cosine of 225 and the sine of 225. Technically 1 times that and 1 times that. So all students take calculus. Should this cosine of 225 be positive or negative? Negative. What's the reference angle? From 180 to 225. 45. Cosine of 45, you shall know tomorrow. Negative is root 2 over 2. The sine of 225, should that be positive or negative? Negative. Reference angle is 45, obviously. That doesn't change. Sine of 45 is also root 2 over 2. Does that make sense? Yes? Okay. Homework is coming out. Corrections are